Good morning, geometry class. Hope everybody's doing well. Everybody did an excellent job on your checkups. I'm glad to see that everybody is progressing and doing really well there. Continue to memorize those formulas as we are going to add some new formulas this morning. So I'm really proud of all your hard work. Continue to work hard. We just want to quickly ask God's blessing. We're going to pray, get right into it. This morning we're going to look at page 22. Last night for homework we had to do numbers 5, 6, and 7 on page 22. We'll do that quickly, and then we'll get on to our new topic. So let's pray, shall we? Dear Lord, thank you for our time together. Bless our time. Give me, the teacher, wisdom, the student wisdom as well. Give them, I pray that they would work hard and work diligently in applying these rules and principles and theorems that we studied in class. And we'll thank you in Jesus' name. Amen. All right, so let's get right into it here. Yesterday we looked at polyhedrons. Now let's not forget, a polyhedron is a three-dimensional enclosed region of space. And there are two types of polyhedrons that we looked at yesterday. There were prisms and pyramids. Prisms and pyramids. And so a prism is a polyhedron with at least two congruent faces in parallel planes, and then a pyramid, is a pyramid whose base is a regular polygon and whose lateral edges are congruent. Now, we did learn yesterday that we will name a prism or a pyramid by the base. So whatever shape the base is in, whether it's a rectangle, it'll be a rectangular prism. Triangle will be triangular prism. Things like that, okay? So just so you know, you want to continue to study those and be up to date on that. Page 22, number 5, 6, and 7, we see, find these lengths in a regular triangular pyramid if all lateral faces are equal lateral triangles. AC is 10 meters, and DX, which is, you'll see here, right coming down the side there, all right, DX is the altitude of triangle BDC. So triangle BDC is, you'll see this on the side there, that's triangle BDC, okay? Now, here's the hint. Use a calculator with the square root function. Round off answers in two decimal places. Hint, use the 30-60 right triangle theorem, the 30-60 right triangle theorem. So let's not forget what that 30-60 right triangle theorem is. And so if we want to find the hypotenuse, it's C equals to A, and then B equals A times the square root of 3. So 30-60 right triangle theorem. So let's quickly find the lengths of CD, the length of CX, and the length of DX. So CD, okay, so we notice here CD would be the length of, let me make sure I have them right here, CD, CX, and DX, okay? So CD. Now, since we have a triangle here, notice the direction set is in an equilateral triangle. And so if the side here is 10, then this side DC, where CD would be simply 10 meters, right? Equilateral triangle. All the lateral faces are congruent. Now, the next thing we want to do is we want to take that, we want to find the length of CX. So again, equilateral triangle. So if this is 10, we know that CB, okay, so the triangle facing that way, CB will also be 10 meters. Now, the question is, we want to know the length of CX. So this is an altitude. We know that this altitude here is perpendicular to the base, but it also bisects the base as well. And so we know that it divides a line segment into two equal parts. So if CB is 10 meters, then CX would be what, class? 5. Very good. So CX, right? If we want to quickly just show that, so I'm just going to put CB, right? CX is equals CB divided by 2, which is 10 meters divided by 2, which is simply 5 meters. Okay. Lastly, we want to find the measure of DX. Okay, so DX is the altitude. Now, I want you to quickly, if you can picture this, if you can see this clearly, all right, so we have, I'm going to try to highlight this a little darker. You see this triangle right here, okay? This is the triangle that we're looking at, all right? we want to find the length of dx. So, using the 30-60 right triangle. So, if this is the right angle, this line here would be what in a right triangle? If this is the right angle, this would be the hypotenuse. Very good. So, we're going to go 10 meters equals 2a. 10 meters equals 2a, okay? And so we would have here, divide both sides by 2, and a equals 5 meters. Then once we get that answer, we're going to plug that into line segment B. Okay, so this is A. We want to find line segment B, which is dx, and all we're going to simply do is take this A, we're going to plug it here. So we're going to have 5 to the square root of 3. Now, the directions say if we have a square root function, we want to make sure we use that square root function. So find the square root of 3, times it by 5, and you shall get 8.66 meters. 8.66 meters there. Okay, so again, last pace, finding the sides of right triangles. Pythagorean Theorem, the 30-60 right triangle theorem, also the isosceles right triangle theorem, okay? That was your homework last night. Hope everybody got that. And if not, make sure you copy that work down so you can study. Let's look at page number 23 in your notes. Page number 23 in your notes, we're going to see the area of a right prism. Now, I'm just going to quickly step off camera for 1 second here, and I'm going to grab grab a cereal box, okay? So I'm just simply going to illustrate this. All right, page number 23. You'll see this inside in your notes there. All right, let me just open this box up, okay? How do I find the total area of a right prism? Okay, so here we go. So we have a cereal box here. How can I find the total area of the various shapes that are on this box? If I were to open this box up, so you notice here how we have the flaps or rectangles, right? We have the top and the bottom here, the faces here. But if I were to hold this open, you would see that we have one giant rectangle. One giant rectangle, okay? This is called the lateral area. The lateral area is the sum of the areas of the lateral faces. So we have one giant rectangle. Now, also you'll see up top here and the bottom. So this top flap here, this bottom flap here. And so these would be our bases. Again, they're rectangles. And so if we're going to find the total area, we would find the area of the lateral faces, all right, that one big rectangle, and then we would take it and add it to the area of the bases. So the top shape here, the top rectangle, and the bottom, that would be the base, right? So if I were to close this cereal box, you would see here the base, the top, and the bottom, okay? And so that's how we illustrate that. And so I want you to see here the formula. You need to again highlight these formulas. Very important to know. The lateral area. So we're talking about the area of a right prism. The lateral area is pH. I'm going to write that on the board here. Lateral area equals pH. And so what we want to do here, P is going to stand for perimeter, and H is obviously the altitude or the height. So since it's a rectangle, the perimeter of a rectangle is, you remember, 2 times the length plus 2 times the width. Very good. And then we want to find the total area. So remember, this is a right prism here. So the total area would be, obviously, the answer from the lateral area. Okay, we would just find this answer, plug it in here, and then add it to 2 times the base. Whatever shape the base is. In our cereal box illustration, the base was a rectangle. So we would just simply find the area of the base of a rectangle, which would be base times height. If it would be square, we would use base equals s squared. Okay, or if it was a triangular base, it would be 1/2 times the base times the height. So let's quickly look at this. Let's look at number 2 on page 24. Let's apply this, okay? So let me draw our shape here. All right. We have a computer base there. So, all right, we have 30 centimeters, we have 38 centimeters, and we have 15 centimeters. I hope everybody can read that clearly, okay? So what we want to do is we want to find the lateral area. So the lateral area, again, we want to make sure that we understand this. The lateral area of a prism is the sum of the areas of the lateral faces. So we're going to go, so the perimeter times the height. So what kind of shape do we have here? We have a rectangle. So the perimeter of a rectangle would be, okay, so I'm just going to, I'll write the formula in, all right, and then we'll plug it in, okay? So we have, okay, 2 times the length. So we have the length of the CPU here. It's 38 centimeters, so we're going to go 38 centimeters, all right, plus 2 times the width. So the width is 30 centimeters times the height, which is 15 centimeters, all right? So let me put that in brackets here, okay? All right, so now we're just going to multiply. We're going to take care of our brackets first. So our parentheses, then our brackets, and then we'll multiply here. So, okay, get your calculator out. I want you to do this with me at this time. So 2 times 38 is going to be, okay, get your calculator out. What do we have here? 76 centimeters, okay? All right, plus 2 times 30 would be 60 centimeters times 15 centimeters. Again, I know we could skip steps. If you know what you're doing, you could move through, but I just want to go step by step because I want you to see how this goes here. All right, so we have 76 plus 60, so we have 136 centimeters times 15 centimeters, and you should come up with the answer of 2,040 centimeters squared. Again, if we're looking at area, right, centimeters times centimeters is centimeters squared. Now, that's the lateral area. Now we want to find the total area. So the total area would be the lateral area plus 2 times the base. We already know the lateral area, so I'm going to plug that in here. So total area equals 2,040 centimeters squared plus, 2 times the base. What shape is the base? It's a rectangle. Very good. So 2 times, the formula for the area of the base would simply be the base times the height. Okay, so let me again just do it longhand so you can see. All right, 2 times, okay, the base again and the height. So what do we have for the base of this rectangle? So we have 38, excuse me, 38 times 38 centimeters times 30 centimeters, okay? All right, so I'm just going to bring us down now, 2,040 centimeters squared plus, okay, 38 times 30 and then times 2 gives us a total answer of 2,280 centimeters squared. Just simply add those up and our answer is 4,320 centimeters squared. So there you have it. Finding the lateral area, okay? So to find the lateral area, since we're dealing with a rectangle, we find the perimeter of a rectangle times the height. That gives me the total lateral area. Again, okay, so this rectangle in here, that's the lateral area. And then we find the area of the base again, which is simply the bottom or the top and the bottom. So great job there. Okay, so let's do number 3, okay? Typically we'll do evens or odds, but I wanted to do one rectangular base and I want to do one triangular base here. So, all right, let me erase this. Hopefully you copied your work down. Okay, copy your work down here. All right, so we have, let's draw this. All right. Okay, not easy drawing your shapes, these shapes here. Okay, all right, looks like a wedge of cheese, all right? So we have 4 meters, we have 5 meters, and this is perpendicular, and this is perpendicular. Okay, find the lateral area. So again, perimeter times the height. So perimeter times the height. So let's look at this. Again, what is the shape of our base? So we have, the shape would be a triangle. So how do I find the perimeter of a triangle? Right? Remember, the perimeter is the distance around an object. So we're just going to simply add the distance around. I think I'm missing one. Yep, that's 3 meters. Okay. All right, so I'm going to write the formula here. Lateral area equals, all right, so I'm just going to go, again, I'll do this longhand, so 4 meters plus 3 meters plus 5 meters times the height, So again, I think I missed another one here. I did. The height is 9 meters. Okay, so get your calculator if you need it. 4 plus 3 plus 5 is 12 meters, right? 12 meters times 9 meters. Okay, so 12 times 9 is 108 meters squared. Real simple. Now we're going to take that, the lateral area, we're going to plug it in to our total area. So 108 meters squared plus 2 times the area of the base. Okay, so again, what shape is the base? The shape is in the form of a triangle. So 2 times 1/2 times the base times the height, which is the area of a triangle. So let's plug in our information. Okay, 2 times 1/2. Now, the base and the height. So the base and the height are, again, 3 meters and 9 meters. So, running out of room here. All right, so let's, again, doing this longhand, you could skip some of these steps or do these steps in your head. Okay, we have, obviously, we could cancel out the 2 and the 1/2 there, right? So that'll just simply be 1. And then 3 times 9 is 27 meters squared. Okay, 27 meters squared. So, let's see, did I get that right? Did I put that down right here? Base times the height. So 3 meters times, I'm sorry, this was not the height. I'm wrong. Forgive me. Obviously, the altitude is always perpendicular. I don't know how I missed that. So always perpendicular. So this would be 4, which would make this 12. And then 108 meters plus 12 meters is simply 120 meters squared. So take it from me, when you don't pay attention, I almost cost us the wrong answer there. And I bet you were all copying it down saying, yeah, you got it right, Pastor Don. Don't follow me sometimes. Sometimes they may mislead you wrongly. Make sure you follow the rules. So obviously the altitude is always perpendicular to the base. That's how we would know that. All right, let's do one more. Let's do number 6, okay? We'll do number 6 together, and then we'll move on to the next page here. Number 6 we have, How much wood is needed, or how many liters of paint are needed to paint the walls of a learning center that is 14 meters long, 10 meters wide, and 3 meters high if 1 liter will cover 10 square meters of surface? Okay, so how many liters of paint are needed? Okay, so let's do that one together. We're talking about a classroom. The walls are 14 by 10. That sounds like a rectangle. So we're going to go, the lateral area is equal to, all right, again, 2 times the length plus 2 times the width times the height. Okay, so let's get the dimensions of the classroom that are given to us in the problem. And so the dimensions are, okay, 2 times 14 meters, I believe it is. Yep, plus 2 times 10 meters times the height of the classroom, which is simply 3 meters, okay? So let's quickly multiply those together. So, all right, 2 times 14 would be 28 meters, plus 2 times 10 would be 20 meters times 3 meters. Okay, 28 plus 20 is 48 meters, plus or times 3 meters, and then 48 times 3 is 144 meters squared. Now, what is the total area? We want to get the total area. So if we have, how many liters of paint? So if we have the lateral surface, again, this is how you would discover how to paint a room. So if the lateral area is 144 meters squared, and then the problem says that 1 liter will cover 10 square meters of surface, how many liters of paint would we need to cover? So we would just simply go, all right, I'll just write it up here on the board. So 144 meters squared is, okay, times our coverage. So our coverage again is 1 liter per 10. So let's go, we'll go 1/10 meters squared. All right, so 144 meters squared times 1/10. All right, so meters there will simply be, just move the decimal one place, 14.4. All right, 14.4, that would be meters, 14.4 liters, okay? I think this should be liters, okay? Very good. So that's the answer there, 14.4 liters, all right? So that's number 6. I want you to do, well, just save that, all right? Don't do anything for our homework just yet. All right, let's close. We're going to look at page 25 and page 26 as we round up this class here. So this, what we just got done doing, was simply the right prism, finding the lateral area and total area of a right prism. Now we're going to look at page 25, which talks about the area of a regular pyramid. The area of a regular pyramid. So one thing we want to look at the area of a pyramid, if you look down in your text there in the very second paragraph, the pyramid on the right is labeled A, which is the vertex up top, and then the base is a rectangle. So you'll see it's B, C, D, E. A lateral face of this pyramid is the triangle with the altitude of AX or L. So I want to draw your attention. Okay, here we have the vertex. Here we have the base. All right, so this line here that's perpendicular to the lateral edge, so AX, is what is called the slant height. It is not the same as the altitude, okay? The slant height is only the length of the lateral face. So make sure you understand that there, okay? And the symbol for slant height is going to be L. So we got to take that into account when we're figuring out the area of, figure out the lateral area, okay? So again, it's not the altitude of the pyramid, but the altitude of the triangular lateral face. Be sure you understand that, okay? So now, I'm just going to put here, this was right prism, okay? And this we have a regular pyramid. Okay, so regular pyramid, lateral area is equal to, okay, let's look at the formula there. Again, highlight these two formulas. 1/2 times the perimeter times the slant height. The perimeter times the slant height. And then we have the total area will equal 1/2. Again, the answer to the first problem. Plus, you'll see here, it's just simply the base. So let's just do a couple of these, okay? If you would join me, let's look at number 2. We'll do number 2 and we'll do number 4, okay? Number 2 and number 4. All right, let's find the lateral area. So let me see if I can draw here my triangle. It always helps, I guess, to do the base first. Okay, and then we have our slant height. All right, so we're looking at here, this is 9 centimeters, this is 6 centimeters. 9 centimeters and 6 centimeters. So typically for these regular pyramids, you're going to have 2 bases. You're either going to have a square base or you're going to have a triangular base. Okay, so we'll kind of look at that here. So we have here, let's find the lateral area. Okay, let's find the lateral area here. So again, the lateral area is 1/2 times the perimeter times the slant height. Times the perimeter times the slant height. So we're going to be page 6, 26, number 2. All right, page 6, number 2. Now, one of the things, in order to solve this, we need to have the slant height. Notice we have one of the lateral edges. Notice we have the base, but we don't know the slant height. So, again, follow along with me here. We have a right triangle. You see the right triangle here, class? So let's just say this side of the right triangle is 9 centimeters. All right, this side we have 6, and 1/2 of that would be 3 centimeters. Notice, I have 2 sides of a right triangle. I have to find a third side. What equation can I use to find the length of a side of a triangle? Pythagorean Theorem. Here it comes again. We're going to see it over and over and over again. So before I can find the slant height, I must first use the Pythagorean Theorem. So I'm going to go c squared equals a squared plus b squared. Now, all right, if this is my right angle, what is that? That is the hypotenuse. The hypotenuse. So 9 centimeters squared is equal to, and then we have a squared, which is, okay, so we're going to look at here again. So we have 3. So 3 centimeters squared plus b squared. All right, so 9 times 9, we have 81 centimeters squared equals 9 centimeters squared plus b squared. Now simply we need to subtract 9 centimeters from both sides. Again, you could do this with your calculator. You don't need to show all that work. So b squared equals, and then 81 minus 9 gives me 72 centimeters squared. 72 centimeters squared. Find the square root of both sides, and b is going to equal, I'm just going to simply put 6 to the square root of 2. Now if you want to if you want to put a decimal here, just simply find the square root of 2, times it by 6, and you'll get the decimal answer. But that is the length of our, I will draw an arrow, the altitude. Now that I have all my information, I could plug it in and find the lateral area. So the lateral area is 1/2, all right, times, again, the number of sides. So, okay, how many sides do we have in our base? Remember, the perimeter of our base, okay, we have, it's a square base. So what's the perimeter of a square base, right? It's 4s, right? The number of sides times the number there. So we have, all right, 4 times 6, 4 sides, all right, let's see here, centimeters, times 6 centimeters, and then times the slant height. The slant height is 6 to the square root of 2. All right, I'm writing a little too big here for my board. All right, so we have 24 centimeters squared times 6 to the square root of 2 centimeters. Okay, let's do our math here, okay? So we'll have 12 centimeters squared times 6 to the square root of 2 centimeters, which is 72 to the square root of 2 centimeters squared. Which, again, if you're using a decimal, it's okay. All right, so if not, we'll turn this into a decimal. Your answer should be the same as mine, 101.82 centimeters squared. So first find the length of that third side. Then we're going to plug that into our lateral area. And then we're going to take it and plug it into our total area, which is 101.82 centimeters squared, right? Plus the area of the base. Again, what's the base? In a regular pyramid, we're dealing with just two bases. Either it's a square base or a triangular base. So this is a square, so all we're going to do is s squared. S squared. So we're going to take that and we're going to go 6 centimeters squared. 101.82 centimeters squared plus 36 centimeters squared, and that should give us a final answer of 137.82 centimeters squared. So 3 steps. Step 1, first I had to find the slant height. I used the Pythagorean Theorem. Step 2, found the lateral area. Step 3, found the total area, which is 137.82 centimeters squared. Let's do one more problem together, and then we'll wrap it up for this evening. This morning, let's look at number 4. Number 4, okay? We'll do number 4, and then we'll pack it up for today. Okay, number 4. So let's see if I could draw my triangle here. All right, and so we're going to have a triangular base. All right, and then our slant height would be right here. Okay, there's our slant height. All right, so we have 10 centimeters here, and then we have 12 centimeters here, okay? Now, all right, let's quickly do this problem together. Again, we have 10 centimeters. This is a equilateral triangle here, so 10 centimeters. And so what we're going to do now, we got to find the length of our third side. Here's our right angle, okay? Okay, the whole side here we're going to go is 12, so we're going to make this, split this in half. So this becomes 6 centimeters. I just got to find the length of the third side, which is Pythagorean Theorem. So the Pythagorean Theorem again, so we have, okay, again, here's the right angle, there's the hypotenuse, so 10 centimeters squared plus, whoops, equals 6 centimeters squared, all right, plus b squared, so 100 centimeters squared equals 36 centimeters squared plus b squared. Okay, we're going to subtract both sides, 36 from both sides. That gives me 64 centimeters squared. Find the square root of both sides again. So b is equal to, the square root of 64 is 8 centimeters. There you go. There's your altitude, 8 centimeters. Now that I have all 3 sides there, we can now come and figure out our lateral area. So our lateral area equals 1/2, okay, times the perimeter. Again, we have the perimeter of a triangle, so we're just going to simply take all 3 sides here. So 3 centimeters times 12 centimeters, and then we're going to times that by the altitude, which is the slant height, excuse me, not the altitude, 8 centimeters So 1/2. Okay, so simply we're going to go 3 times 12. All right, so that's simply 3. That's not 3 times 12. So 3 times 12 is 36 centimeters times 8 centimeters. All right, 36 times 8 centimeters would be, now I like to, for me, just get rid of that fraction real simple, real quick like. So 1/2 of 36 is 18 times 8. And then 18 times 8 gives us an answer of 144 centimeters squared. All right, we're going to take that. All right, now solve our total area, which our total area is going to be 144 centimeters squared plus the base. 144. All right, so what is the area of a base? Since we have an equilateral triangle, our base is going to be s squared times the square root of 3 over 4. All right, so total area equals 144 centimeters squared plus, all right, now side squared. Come back to our triangle here. So our side is going to be 12 centimeters. So 12 centimeters squared times the square root of 3 over 4. I hope you can see this. I know it's a little small. I've come run out of space on my board here. So we have 12 times 12 is going to be 144 centimeters squared times the square root of 3 over 4. All right, then from there, 144 centimeters squared. Okay, now we have 144 times the square root of 3 over 4. Now we can, okay, we can divide that. We can reduce that basically. So that gives me, all right, plus 36 to the square root of 3. All right, 36 to the square root of 3. And then how do I add these? 144 plus, I'm going to simply convert that to a decimal. So 36 times the square root of 3. Get your calculator out. You'll find that that equals 62.35. And then add those two together, and your total area is 206.35 centimeters squared. 206.35. So again, using those 3 steps, making sure that you're finding that length of the altitude. Once I find the altitude, I can plug it in. Okay, so what I want you to do for homework today, I want you to do the page 27 and 28 for homework. I want you to do page 27, 14 and 16. And then on 28, I want you to do 18 and 19, 20 and 21, and 26 and 27. Okay, do those for homework, and I'll have those in by tomorrow at 3 o'clock. All right, have a great day, and hopefully I'll see you tomorrow.